Alright guys, this is Unit 11. We're going to talk about what's called trigonometry. Trigonometry just basically means angles and measures of triangles. So, everything we're going to do in Unit 11 has to deal with right triangles. We'll get into non-right triangles next year in Secondary 3. So, but today we're going to talk, I'm just going to go to the notes, I'm going to jump over the starter. So, we're going to talk about the Pythagorean theorem and then special right triangles. So Pythagorean theorem can only be used on right triangles. This is the definition of it down here. It's really wordy. What it basically means is this equation where a squared plus b squared is equal to c squared. And the key for this is knowing which one is c, which side of the triangle is c. And it is always the hypotenuse. Hopefully you guys know how to find the hypotenuse, but it's always across from the longest side. The longest side in any right triangle, let's go to example 1 down here, is always across from the right angle. The right angle's, the 90 degree is always the biggest angle because the other two angles together have to equal 90 degrees for it to be 180 degrees inside a triangle. So first thing you're going to do when you're doing Pythagorean theorem is label which side is C, which side is the hypotenuse, and then A and B, you can interchange them, it doesn't really matter. Just pick one to be A and one to be B. Now we're going to substitute all of this stuff into the Pythagorean theorem. So we have 5 squared plus 12 squared is equal to x squared, because this is what we're looking for. So 25 plus 144 is x squared. We had 25 plus 144 and we get 169. Then when we take the square root of both sides, x is equal to 13. So the side length of this one is 13. Okay, let's go to B. We're going to label our hypotenuse first. 14 is our hypotenuse because that's our longest side across from the 90 degree. And then the other two sides are A and B. Now we're going to substitute in, so we have 7 squared plus x squared is equal to 14 squared. This is why it's important to know which one is C, because now we're going to solve for this right here. So 49 plus x squared equals 196. And then we're going to subtract 49 from both sides. And x squared will equal 147. Now we're going to take the square root of both sides. 147 is not a perfect square root, so you do need to do a factor tree if you don't have a Casio. We'll do it for you in the Casio, but you end up with 49 and 3, and 49 is 7 and 7, which is your pair. So x is equal to 7 square root of 3. Alright, we're going to go to a real world problem. This is finding the approximate length, which means we don't want square roots here, we want a decimal answer. And let's say we're going to round to 2 decimal places. Alright, so we have a skyscraper, actually 2 skyscrapers that are have like a sky bridge or a skywalk. We want to know how long the support beams are, which are these. So we have this right triangle. I'm going to recreate this. We know that this short length up here is actually half of this, so 23.26 divided by 2, so 11.63. We know the length of this one down here because it tells us it's 47.57. These are all in meters. So we need to find the length of the hypotenuse. So this is our C, it doesn't matter which one is A and B. So we have 11.63 squared plus 47.57 squared is equal to x squared, because c, this is our unknown, our x. I only put those in brackets so you don't, parentheses, so you don't think it's 11 times 63. I don't know. You don't have to really do that in your calculator. But this ends up being 135.26. And this is big number 2262.90. So we add these two things together. And we get 2398.16 is equal to x squared. Then we do take the square rootable sides. We end up with 48.97 meters. So the length of each support beam is 48.97 meters. All right, Pythagorean triples in your packet. You should have them already filled out. But Pythagorean triples are like this one up here. This is a Pythagorean triple because the numbers are whole when they end up. Also a 3, 4, and 5 is a Pythagorean triple if I have a right triangle. And these two sides are 3 and 4. The hypotenuse will be 5. So 5, 12, and 13 are Pythagorean triples. And I think you guys have 2 or 3 more examples that I can't remember what they are right now. Okay, special right triangles on the next page. What I want you guys to do is solve each of the following triangles. Leave your answers in reduced radical form, so I don't want any decimals. So Pythagorean theorem on them. They are right triangles and we know 2 of the sides. So this is our A, this is our B, and this is our C. So we have 4 squared plus x squared is equal to 8 squared. And I'm going to let you guys do the work. I want you to do it, but you end up with x is equal to 4 squared to 3. So what you're going to do is you're going to fill this out. So the short leg on this is 4. The long leg is 4 square roots of 3. And then we have our hypotenuse, which is already filled out at 8. On the second triangle, short leg is 6. And the long leg is 12. When we do the Pythagorean theorem, so this is A, B, and C, so 6 squared plus x squared is equal to 12 squared. When you do this, you end up with 6 square roots of 3. Then on the last one, it only gives you the short leg. We have an 8. The long leg is going to be 8 square roots of 3. And the hypotenuse is going to be 16. Okay, I want you guys to think about this or pause the video. What do you notice about the angles and the sides of the triangles? Okay, let's go back and look at the angles. This one's 30, 90, it has to be 60. This one's 30, this one has to be 30. So these are called a 30, 60, 90 right triangle. Or 30, 60, 90 triangle, 30, 60 right triangle, whatever. Their sides always follow in this pattern right here. Okay, we'll go over exactly what the pattern is in just a minute. We have our second type of triangle. We have 45 here, which means that this one is 45. Remember, these marks mean that both of these are equal. Okay, so we're going to do the Pythagorean theorem on this. This is my A, and this is my B. This is my C, because this would have to be our 90 degree. So 6 squared plus 6 squared is equal to x squared. So 36 plus 36 is equal to x squared. So 72 is equal to x squared. We take the square root of both sides, and x is equal to, after I do a factor tree, this is 6 square roots of 2. So first triangle, our legs are both 6 and 6, and this is 6 square roots of 2. On the second triangle, we have 10, and 10. And then when we do Pythagorean theorem, this is A and B, C. So 10 squared plus 10 squared is equal to x squared. So 100 plus 100, 200, which when we do the factor tree, x is equal to 10 square roots of 2. Okay, these two triangles, these are a 45, 45, 90 triangle, or 45, 45 right triangle. They always follow a pattern too. The two short sides are the same number, and then the third one is the 10 square roots of 2. So let's go to the next page. I think you guys' packet has been fixed where it says triangles on here. These are special right triangles. If you can recognize these two patterns, the 45, 45 right or the 30, 60, 90, they always this is the two shorter legs multiplied by the square root of 2. Right here we have the shorter leg times by 2. And then the shorter leg times by the square root of 3. So this always follows x square root of 3, and the hypotenuse is 2x. Okay, so if you only have one side of one of these special right triangles, you can figure out what the other two sides are. This is our 45, 45 right triangle, so the two short legs are both 8, and then x would be 8 square roots of 2. Because we multiply the shorter sides by the square root of 2. If we have a 45, 45 right, which this one, since both x, these would be the same length, we're going to divide by the square root of 2 since we're going from the hypotenuse. So we have 5 square roots of 2, and then we're going to divide by the square root of 2, which means that we can cancel out the square root of 2. So both of these are a length of 5. Okay, finding side lengths in the 30, 60, 90 triangle. If we start out with the shortest one, which is right here, that means that our hypotenuse is that times 2, so this would be a 6. And that would mean y, we're going to multiply by the square root of 3, so this would be 3 square root of 3. From the pattern up here. Okay, so here we have the longer side. To get to the shorter side, instead of multiplying by the square root of 3, we're going to divide by the square root of 3. So 9 divided by the square root of 3 is going to be this side. And then that means that our y, that's 2 times that. When we multiply this by 2, we just multiply the number. So it would be 18 divided by the square root of 3. So the two side lengths we were missing are 9 divided by the square root of 3 and 18 divided by the square root of 3. Okay, this one. My short side is the square root of 3. To get to the hypotenuse, we multiply that by 2, which means we just put a 2 in front of it. And then we're going to multiply by the square root of 3 to get to x. So we have the square root of 3 times the square root of 3. To multiply those together, and we get the square root of 9. And the square root of 9 is just 3. So the length of this is is 3. This is 2 square roots of 3. We just leave all of these in reduced radical form. I don't want any decimals at all. Okay, you guys have your homework. We're going to do the Pythagorean theorem, and you're going to do some special right triangles. So make sure you are looking for this. Then you're going to use the Pythagorean theorem to figure out if the following two triangles are right triangles. See if you can figure out how we want you to do that. Then down here, number 12, this is where we have special right triangles. I think we fixed your instructions to do that, but you guys should be able to do this. Please email me if you have any questions. I'll be checking my email a little bit. I am on the golf course with the golf team, but thanks, guys.